Hello, everybody. Today we're going to be doing question 2 for the ratio test for convergence review sheet. If you have any specific questions about the ratio test, there's another video that you can watch. So let's get into number 2. Determine whether the following series converges or diverges. We have our following series here. So it's the summation from n equals 1 to infinity for this series of n factorial divided by 8 to the power of n. So first and foremost, for ratio tests, we are finding the limit as n approaches infinity for the absolute value of a sub n plus 1 divided by a sub n. So our first step is that we want to determine what our a sub n is and our a sub n plus 1 is. So a sub n is just our series itself. We're just leaving the n alone. So it's our a sub n in this case is n factorial divided by 8 to the power of n. A sub n plus 1 is we are now substituting n plus 1 into any time we see n. So in this case, we see n plus 1 here where there was an n originally. We see an n plus 1 here where there was an n there originally. So our a sub n plus 1 is parentheses n plus 1 factorial divided by 8 to the power of n plus 1. So let's get into it. We're going to now take the limit of this here. So we have the limit of n, or limit as n goes to infinity for the absolute value of a sub n plus 1 divided by a sub n. So when we substitute in our actual numbers here, right there, that's our first step. And then if you notice, our second step here, we get rid of the absolute value bars. And that's because we don't need them anymore. All of our values will be positive, so there's no need for them. You also may notice that we have a multiplication symbol here, we have a division symbol here, and that's because we have two fractions being, or a fraction being divided by another fraction. So this is our first fraction, and it is being divided by this fraction here. When you have a fraction being divided by another fraction, we take the reciprocal of the bottom fraction here, and we multiply that. So that's what you see here. From there, we then can, expand some terms and simplify other terms. So first, what you might notice is that n plus 1 factorial changes into n plus 1 times n factorial. And that's because when you writing n plus 1 factorial, it's n plus 1 times n minus 1 dot 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 till you get to 1. This here is also that. It's saying, okay, n plus 1 times n factorial, and n factorial is then n times n minus 1 dot 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 till you get to 1. So essentially, that is the exact same thing. We also see that this here has been rewritten. So we have 8 to the power of n plus 1. It is being rewritten as 8 to the power of n times 8, just so it's simpler and easier to see. It's the same exact thing. From there, we can cancel out some of our terms. So we have a n factorial in our numerator here and an n factorial in our denominator here. We have an 8 to the power of n in our numerator here, and we have an 8 to the power of n in our denominator here. From there, we have this simplified version where it's the limit as m approaches infinity for n plus 1 divided by 8. Our numerator has an n in it. Our denominator does not. When the power of our variable is higher on the top than the bottom, this means that the top is growing much faster than the bottom. Thus, it's approaching infinity quicker. Therefore, this limit is approaching infinity. Thus, infinity is bigger than 1, and therefore, it diverges.